In this video, we are going to explore all the properties of quadratics, but very importantly, which are the situations that we look with quadratics, and why is it that we actually focus in very specific characteristics. In this case, we are going to focus on the x-intercept. So first of all, what is a quadratic function? A quadratic function is a function that looks like a u. Now, in this example, the u is facing up, but it can easily face upside down. Now, in this type of function, we don't have a slope, we don't have a constant rate of change. So this is very different than a linear. That's why it has a curve. But what is it that I use it for? That is the key. What do we use this function, this u shape, what do we use it to replicate, or what do we use it to explain? So we have a couple of examples right here. If we are going to kick, or for that matter, throw a ball, the ball will have a starting point, take some sort of height, a maximum height, and then fall again. And for most of you that actually play sports, you know that the main um, focus of you doing something of this sort is for you to know exactly where is it going to land. Now, we can use a quadratic or a U shape when we actually do some sort of snowboarding, sorry. And again, our focus will be exactly where do we land if we want to be in a safe place, and obviously where do we need to take off, right? Same thing if we are doing some motor crossing. We would like to obviously know what will be a safe landing. Now, all this obviously is related to a quadratic function, and it's always the base numbers, but that's not it. We also have some examples. What if we want to play? We have some examples, like in this one right here. We have an angry bird, and we know that this is what we call parabolic throw, meaning I throw something, gets to a height, kind of like a ball, and then lands again. And in this case, I would like to be able to calculate or predict very well exactly where my landing points could be if I want to win my game. And ultimately, if we want to be very adventurous, or for some people they are, we have this example of a bungee jump. Now, in this case, why would I be so infatuated with which characteristic of my parabola or my quadratic? And that'll be still this point right here, or the lowest point. They will not, I wouldn't like that point to actually reach my x-axis. Now, all of these different examples that I just gave you actually represent in the parabola the x-intercept, the x where the parabola or the quadratic will cross the x-axis. Like in this example, I wouldn't want to have an x-intercept. I wouldn't like to touch the x-axis because that means that I'm touching the ground here. I would like to know exactly where I'm going to land. So all those will be my x-intercepts, or when I touch the x-axis. And same thing here, where I land. I want to know exactly where I'm at. All of those are x-intercepts. But for a quadratic function, the x-intercept is so important. It's such a big deal that we actually have different names for it. And that's what this is. The R represents for roots. That means that in quadratics, if I ask you for the root of the quadratic, because I really want to know for this situation where am I going to land, we can call it the root. O stands for zeros, the zero of the function. X actually is for x-intercept, which we have seen that before. And S stands for solution. In other words, what we are saying is that the x-intercept, which we know already, wherever my quadratic in this case is going to touch the x-axis, is so important that I actually have four names for it. What are the four names? roots, zero, x-intercept, or even a solution. So every time that you guys are working with a quadratic, a u-shape function, remember the x-intercept, the zeros, or roots, or solution, it's a very important part of this situation.